All right, well, thanks for having me as well. It's very nice to be here today. My name is Pierre-Yves. I'm CTO and co-founder at Exoscale. We're a Swiss cloud hosting provider. Check us out if you need capacity over there. We try to build a company around the notion of being good open source citizens, and we do participate in plenty of projects. I hope you use some of the tools I participate in, like Riemann or Collectd. And yeah, today I'm going to speak about Cyanite, which is one of the projects that started out as a side project at Exoscale and then went on to have a more full-fledged project life. The aim today is to quickly go through graphite, talk a bit about the ecosystem, but I'm pretty sure everyone here is really familiar with it. So I'll try and go quick on that. I'll talk a little bit about the internals to showcase some of the problems that people might reach at a certain scale, and then give a bit of feedback on what Cyanite provides as an alternative, how it was put together, and some feedback on usage in production as well. So that's the outline. That's basically what I just said. I'll start with the graphite overview. If we start from the website, it says that graphite stores numeric time series data and renders graphs of this data on demand. So it has a pretty narrow scope. It's a telemetry-only project. It doesn't have a solution for actually collecting metrics. It relies on submission tools. It also has an optional event storage mechanism, which I won't talk about too much today, because it's a bit orthogonal to the rest of Graphite's duties. In terms of components, there are three main ones: Whisper, Carbon, which is a collection of daemons, and Graphite Web. Whisper is basically RRD written in Python with a few differences that I'll get into, and stores every data point in a separate file. So it's a file-based database. Carbon is a collection of daemons that are asynchronous, provide TCP and UDP interfaces to submit metrics, and has simple storage rules. In terms of actual daemons, the one that you have to interact with, and the only one that you have to interact with when you're on a smaller scale, is Carbon Cache. It's the main daemon, exposes TCP and UDP services, temporarily caches data in memory, and then flushes out to Whisper files. When the I/O strain is quite heavy on your disk, Carbon Aggregator allows you to, at the expense of resolution, to put less strain on the file system by aggregating data for longer periods of time and then flushing out to Carbon Cache. And then Carbon Relay provides a way of distributing metrics to several Carbon caches or several Carbon aggregators, and it's basically a proxy for Graphite metrics. So these are the main backend components, I would say. And then you have Graphite Web, which is I think the oldest and really the biggest in terms of popularity Django project. It provides a way of persisting your configuration, storing dashboards, and user credentials for accessing your metrics. It provides a DSL for data query and manipulation. As you see, the DSL is quite simple. It just allows you to specify a list of metrics to access or apply function on metric paths. It does also graph rendering and has, the composer interface that we all know and love to create our graphs and display our dashboards because nobody switched to Grafana yet. In terms of architecture, it's It's quite simple at first. You'll just have a carbon cache daemon that will accept metrics and which will store two Whisper files, and on the other end a graphite web which will need to know the location to Whisper files and display their content. So on a small scale, it's quite simple and easy to reason about, and a very good solution. Recently, Graphite added some modularity features. It's recent, and we were part of that effort. A module can now implement a storage strategy for a Graphite web. As far as Carbon is concerned, it's a bit more difficult. The way the daemons were built was really tightly coupled to the storage strategies. So the story there is quite different. I'll run through the ecosystem for Graphite really quickly. The first one that most of you know and use is StatsD for application-side metrics. The way StatsD works is just aggregates data for certain windows of time, say 1 minute or 10 seconds, computes counters, gauges, meters, and histograms, and then flushes out to Graphite. Quite simple to, it listens on a UDP port and is quite simple to put in place. I'm very partial to CollectD. It's very popular in terms of system metric collection. It's a very low overhead agent that can pull just about any system metrics, but also is quite capable of retrieving application metrics. It also has a StatsD daemon now that can listen for metrics and then ship off wherever. And in terms of output plugins, it has a very reliable Graphite output that's able to handle temporary restarts in Graphite by buffering data and keeping a very low overhead. Graphite API is an alternative to Graphite Web that we built at Exascale as well, and that shares the data manipulation code that's in Graphite Web. So it has these DSL capabilities, but it's purely stateless. It's basically there if you handle your credentials and your persistence of dashboards elsewhere. For instance, in Grafana, which you all know by now, and which is quickly becoming the default visualization for Graphite metrics. The last one I wanted to showcase is Riemann, because it has a very simple way of outputting data to Graphite as well, and it has a good client story there, and the ability to also service requests to Graphite in an asynchronous queue to reduce latency. And there are a lot more. Syslog-ng and Logstash have ways of pushing metrics to Graphite. There are alternative visualization tools like Descartes and Taseo, and JMX Trends is a simple and effective way to pull JMX metrics from your JVM applications and push them off to Graphite. So overall, it's a great project. It's got a great community. It's quite active, and the ecosystem is ever growing. And I think Grafana really kicked things around a little bit and helped the ecosystem pick up its space as well. And there aren't that many contenders in that space. If you look for a self-hosted solution, the SaaS project, there are several SaaS products available to do that, but in terms of self-hosted solutions, there aren't that many. But it does get a bit complicated when you start to get bigger and bigger. I think the biggest reason is that initially Graphite was essentially a single host solution. It was really a breakthrough when it came around, because all the tools that were available when Graphite came around were just really hugely coupled pieces where storage, display, and input were all coupled. If you look at how MRTG worked or how Cacti worked, they all did Cacti was basically a PHP cron script, right? So it's Graphite really had something new there, but targeted a single host. Whisper file format was built to optimize for space. It's basically RRD in Python, except that it allows you to backfill values when you have metrics that come out of order. You can't really share storage except by going to NFS and all the gremlins associated with that. And it's one file per data point, so as you grow, that usually means quite a lot of disk usage and disk strain. In terms of scaling, most of the techniques have been tacked on after the fact. That you can see that in that several carbon daemon pictures. They came one after the other. And the coupled architecture, not the decoupled architecture, it means that you'll need graphite web and your carbon daemons to know where files reside. So a simple, because it can get much more complicated than this, scaling picture would involve a carbon relay which inputs metrics with a consistent hashing algorithm, sends metrics to the carbon caches it knows about, which will themselves store to Whisper files, and Graphite Web will need to know which hosts the Whisper files live on, and then pull data from there to provide a unified display. But when you look at actual operations around this, it gets a bit hairy in the sense that you'll have to distribute your topology to every node. When a node comes away, or when you want to add a node, you'll have to shuffle metrics around. There are tools that help you deal with that, but it's still something that you'll have to get very intimate with. So all in all, Graphite is still a great project and a great way to get started with metrics. The persistence of configuration, that whole dashboard creation composer, even though the interface is what it is great. The DSL that it exposes is very useful. The functions that are exposed by the Graphite DSL are very comprehensive in what they let you to do. But the project could use newer features like automatic shard assignment, replication easy management, and easier topology changes for the cluster. And this is how we started the Cyanite experiment, in a way. We thought, why not use Apache Cassandra, which is rather good for storing time series, and just keep the Graphite interface out to the world, because that's quite useful and so many tools know how to interact with it. And that's what we did. So Cyanite is basically a Cassandra-backed carbon daemon, carbon cache replacement. It's written in Clojure, which shouldn't be of much interest, except if you want to try and extend it. Leverages both async I/O and threads to try and be really resource efficient. Doesn't deal with Whisper files anymore. Is stateless, so quite easily scalable, and interfaces with Graphite Web or Graphite API through Graphite Cyanite. In terms of duties, the duties of Cyanite are providing Graphite-compatible input methods, a way to retrieve metric names and actual metrics. For this, we revolve around the notions of a metric store to actually store data points, and a path store to store metric names. And both are pluggable. The one that you use alternative implementations for most likely is the path store, because by default it stores paths in memory, and you'll want another method if you scale Cyanite to multiple hosts. The rest is really up to the Graphite ecosystem through Graphite Cyanite, and most people who use it through Graphite API now. In terms of configuration, we try and keep things simple. It has standard YAML configuration file where you're able to say what type of resolutions you're interested in having, where the carbon service lives, and where the HTTP service lives, which will be the way of interacting with the Graphite Web or Graphite API. If you need to use the plugin feature of Cyanite, there's a way of providing an alternative implementation for either a metric store or a path store. There are several that are bundled with Cyanite, but it's also easy to bring in your own by adding classes to the class path of Cyanite. And it uses a simple YAML-based dependency injection mechanism from the configuration file. Graphite Cyanite is the gateway into Cyanite for Graphite. It's a Python module that's available on pip and that needs to be living in Graphite environments and can then just be plugged in through this new modularity feature I was talking about earlier on by just adding a couple of lines into your either Graphite Web or Graphite API configuration. So if we look at the architecture drivers that led to Cyanite, the first one was to optimize for speed and sacrificing storage for speed wherever it was needed. Trying and keeping things simple, and by simple, the idea was to try and have something that would work out of the box without depending on too many moving parts. So keeping that requirement list down as small as possible. Having a story around multi-tenancy, because that was a requirement we had, and many people running large installations had as well. Keeping resource efficient, of course, and remaining compatible with the Graphite ecosystem at all costs. I'll walk through the internals and then talk a little bit about the overall roadmap of Cyanite because it's still being developed heavily right now. So in terms of target infrastructure, you end up with something that resembles the first diagram I had. The point of coupling now is Cyanite and not just the Whisper files because it exposes both the Carbon protocol and HTTP interface that Graphite Web and Graphite API can talk to. And then it needs to talk to a Cassandra cluster. Cassandra was chosen mostly because it's quite good at high write-to-read ratios, which is usually the case for your telemetry infrastructure. Of course, for all the horizontal scalability story around Cassandra, and for the way it stores data through its white column mechanism, which I'll get into right now. So it relies on a simple schema. A metric has a tenant. It has a period and a rollup, which basically determine the precision of a metric. It has a name, its path, the time step for which the metric was input, and a list of metric values for that timestamp that were input. And that's about it. And I was talking about white column, and the basic notion around Cassandra is that it's a hash of hashes, a column family, which will be the equivalent of a table in the SQL parlance, has a row key, which is called the partition key, and determines which hosts are responsible for that key. Here it's a composite. If we look at the primary key statement, it's a composite of the tenant period and precision, tenant precision and path, sorry. And then for each of these rows, you can have an arbitrary number of columns, and they don't have to be homogeneous from row to row. And these columns are sorted, and they're sorted by what's called a clustering key. And in our case, that's the time. And it's that property which makes it quite efficient for Cassandra to retrieve time series for beginning at a certain date and ending at a certain date, because everything will be sorted, and extracting that data will be a low latency operation, provided the cluster is not falling over. And columns may have TTLs so that data gets evicted after a while. So if we look at what we end up with in terms of storage, that's the overall picture. We have a list of rows which are basically tenant to metric and its resolution, and then a sorted array of values for these metrics. And so retrieving slices of these time series is a rather easy operation. We're now going to talk about some of the work in progress items. Cyanite again started as a side experiment, but picked up at a few locations with heavy usage, and we decided to follow up on the initial effort. So there's a rather involved branch that I hope won't fall in second system syndrome, but that has quite a few items being worked on. The first one is DSL support. Even though Graphite API and Graphite Web are great, in terms of initial setup, it's a bit involved to have to install first Graphite Web, then Graphite Cyanite, and point that to Cyanite. It'd be nice if the duties that Graphite Web or Graphite API has today could be performed by Cyanite itself. The bulk of the work there is to expose that DSL and being able to process values. The parser for this, since it's a quite simple grammar, has been written, but there are very few functions implemented yet. We have a nice way of implementing these functions and extending functionality, but it's the bulk of the work remains to be done. The second one is pickle support. So pickle is a serialization format for Python objects, which allows you to just freeze Python object to disk or serializing them for sending over the network. When Carbon daemons speak to each other, they speak through this serialization method. So we have a Clojure implementation of that serialization method that has been finished now, and we're soon going to be able to expose a pickle protocol support. The thing that you get by having this is a nice way of integrating Cyanite in an existing Graphite infrastructure, because you can have a Carbon relay which will push traffic to your standard Graphite deployment, but also to your Cyanite deployment. And that's a great way. That's a dual write method. Gives you a great way of estimating how your Cyanite and Cassandra cluster performs, the size requirements that you're going to end up with for your metrics, and that type of operational insight that's nice to have before completely switching over to a new product. Path storage is a bit suboptimal at the moment. Cassandra is not really good out of the box at dealing with indexes. So when you search for a path that says, give me everything that starts with a web store or something, it's not really efficient to query that type of information in Cassandra. Out of the box, Cyanite does this by storing paths in memory and retrieves that from memory, but that can be resource hungry if your cardinality in terms of metrics is very high, and it's also not great if you restart Cyanite. There is within Cyanite itself an Elasticsearch path store. It's a bit of a I'm a bit sad that most people have to have both Cassandra and Elasticsearch just for metrics. In a sense, it's still the telemetry infrastructure. It shouldn't be such a huge thing. There are other ways that this could be done, and that we will be working on, such as leveraging user-provided signatory indexes in Cassandra, but that will require people to modify their Cassandra configuration a bit. So it's a mix and match of, in terms of working out of the box. Event storage, I'll just mention, the decision so far is to leave that for someone else to care about, maybe Logstash, maybe another system. I see the event storage as a bit orthogonal to the rest of the Cyanite duties. We're open to integrating work like this later on, but it's not a huge priority for us. What is, though, is the support of more input methods in Cyanite. I was talking about the pickle protocol, which is going to be a priority and one of the biggest one right now. But since many projects, such as Collect DC SlogNG, know how to emit data to both Apache Kafka and RabbitMQ, leveraging these queuing mechanisms to input metrics would be very worthwhile, and that's actually what we're doing. I'll talk about this a bit later on. And the last thing is, this could also allow us to expose this StatST protocol for people who want like an out-of-the-box complete solution. It'd be quite easy to add that as well. Providing a Cyanite library for JVM applications who want to push out metrics to Cassandra in a well-formatted way out of the box is something that's been asked for a couple of times, and it's possible today, but it means tearing apart some of the Cyanite code, and it'd be easier to actually have that as a separate library later on. And so the biggest reason we actually built Cyanite for initially was by storing telemetry data in Cassandra, you get the power of all the batch processing frameworks that work with Cassandra, such as Hadoop and also Spark, which is the one that interested us the most. And this allows having standard tools of the trade for data science to work with your telemetry data and to detect anomalies over longer periods of times, or build dynamic thresholds for values which you don't exactly know the correct confidence band for. And we've been doing that. It's a mix and match, but I'll talk a little bit about this further. And the last thing is docs, which currently are quite awful. We've spent quite a lot of time documenting another project we open source, and Cyanite has been really missing in that regard. And I pledge that we will be better citizens from now on. All right. Let's talk a little bit about how it's been running Cyanite in production. The first thing is that the promise of just slapping something that says horizontally scalable on the box doesn't get you to a wonderful place from day one. And essentially what you get is trading the complexity of dealing with graphite and all its moving parts with dealing with the complexity of having to manage and maintain a Cassandra cluster. This is actually why I think the biggest usage of Cyanite has been from people who actually run Cassandra in production for other stuff, because it reduces the technology scope for them. They already have to deal with Cassandra's complexity anyway. And yeah, and optionally Elasticsearch, but for many people in large infrastructure, they're already using it for their block storage, so it's also something that they're used to work with. As far as our usage is concerned, we don't have 100% of our metrics in Cyanite yet, because we started off with graphite. So we still have some there, and we're gradually moving all our inputs to Apache Kafka, and then from there pushing on to Cassandra with a separate input methods that's not in the open source project because it's not quite cleaned up yet. But we do use Cyanite for lookup and interaction with graphite web quite a bit. Elsewhere, we know of a few installations. It's not in hundreds of places. Just a quick show of hands. Is actually anyone in the room using it right now? Awesome. So yeah, we know of a few installations in I guess 20 to 30 companies that we've been in interaction with that do use it. There are always large operations. Most of them, I think, or I'm tempted to say all of them, had Cassandra before. And it goes up to a 50 plus node Cassandra cluster to store metrics. So we're talking about people who have to deal with a lot of those. Even though we're, I guess, more, we do consume more storage space than graphite would, so maybe it wouldn't be such big clusters if it wasn't Cyanite. In terms of the schema, when you collect at very narrow interval, like for instance, if you collect metrics at 1/7 intervals, and if your cardinality in terms of metric names is small, the way the partitioning and clustering is done will put a lot of strain on your Cassandra cluster. So that's something that could be improved and that we'll be working on. We're leveraging SQL collection types. So basically, for a timestamp, we're storing all the data points that we're inputting in a list. That allows us to leverage purely commutative operations on Cassandra, which when you're looking at these eventually consistent data stores is something that you really want to do to avoid the read and writes. So it's an optimization in terms of it, but it turns out that these collection types in Cassandra could be a bit more efficient. And overall, cells should and could be more compact down the road. Again, we made that trade-off to avoid read and write, which would increase latency, but also would be less reliable given the nature of Cassandra. We do use Kafka to solve that problem, and it solves it elegantly, but I still think it's not a valid, it's not something that we should be asking people to install just for the telemetry, because you end up with a huge monster of an infrastructure, again, just for metrics, which might be a bit tough. In terms of maintenance, there are a couple of Python tools that are very useful to deal with pruning all metrics when there is something you don't want to input anymore, to get an idea of the usage of your metrics. There's also a tool if you want to convert Whisper file to Cyanite, and just when you're changing from one to the other, that's been really useful. In terms of Cassandra maintenance, the usual applies if you're used to it. Even though all data is TTL'd in Cyanite, the way delete happens in Cassandra by default is that they don't happen, at least not for 10 days. So you'll have to run these scheduled repairs on the cluster to do the garbage collection process and follow release quite sharply, because they do tend to find and fix bugs that will affect clusters that are on heavy load quite often. The best supported version is the 2.1 branch, mostly because that's what we're using for Cyanite, but there are people who are running on 2.0, and that works well. Anything below, you most likely shouldn't try. There is also in more recent Cassandra version, a different way of performing that garbage collection step, which is called the day-tiered compaction strategy, and that's really something that you want to use if you're using Cyanite. Last words, scaling, since Cyanite is stateless, you most likely won't have any trouble scaling Cyanite. There are a few ways of making Cassandra more efficient. Most of the time it's interesting to collocate your Cassandra and Cyanite processes on machines. And if you have a cluster that's on very heavy load, under very heavy load, splitting data and proxy nodes is interesting because it reduces the latency in queries, and it also reduces the GC pressure on the nodes that actually store data. And that's been a good solution in some places. If you need a simple way of distributing queries going out to your several Cyanite processes, HAProxy does a pretty good job at doing that. So our overall sentiment is it could be better. It does work today, but there are a few pending things that could make it a much more compelling solution, and that we're working on. You'll still hit rough patches if you try it out, but it's moving at a relatively good pace, I would say, and it's been getting the job done. And overall, if you look at the end result, sure, it's not perfect, but the maintenance story is, I think, better than what you get with shuffling Whisper files around with Graphite, especially on larger installations. And that's all I have today. I'm ready to take questions. There are quite a few people who helped us in the process of building this, so big thank you to them. And that's it. Thanks. Yeah.
So I'm kind of curious about, like in Whisper, you have the storage schemas configuration where you determine like how much you're going to keep for each resolution. I'm wondering how that works in Cyanite, and like is it easier to change your mind about how you want to store things over time?
So it's not perfect. The way it works right now is that there's a Cyanite-wide resolution. Let me pull out the configuration. And we have, where am I? There we go. So the rollup section is the section where you define the resolutions you're interested in having. It parses the same format than Graphite, so you can say like 1 day, and each this is actually. Yeah, just plain seconds, but it also understands the same format that Graphite does. So it's per Cyanite process that you define this, and we'll be looking at doing the regex based dispatching if you want to have several resolutions for different metrics. Yes.
So if you change it, is there like a resize thing? Or?
There's not. So yeah, because that would involve It's an open question of how, because at some point you'll have dispatch operations that are needed. We currently run them out of Dent when we have to run them. It's an open question as to how we're going to expose that as Graphite, because it's not supposed to be like an orchestrator of batch jobs, and I don't have a great answer for that yet. Yeah?
You know, actually to that point, I just found out a few weeks ago that for every single time you write to another aggregation policy within Graphite, it also has to create a read for that same thing.
So what? Sorry?
So let's say you have like 1 minute, 9 days, and then 15 minutes a year.
Yeah.
You're actually doing 2 reads for every single write you do to Graphite, and it ends up killing the carbon caches over time. I'm wondering if you have the same issue with the...
So, no, we don't, because, again, we optimize for speed, so all right. Oh, sorry. So the question was, within Carbon, when you have different resolutions, for the higher for the lower precision resolutions, you'll have to read data and then write back out. And how do we? What's the behavior of cyanite in that case? And as I was saying, we optimize for speed, and what we do is we denormalize everything. So when you want to write for 3 resolutions, what we do is we write values 3 times, and that's it. So it's going to consume more space, but you don't have that read and write behavior, which would kill latency. All right, thanks a lot.